Okay, so we have a system using whatever numbers belong to you. So one example of the system might be this, using 5 for A, 7 for B, and so on. So here's the system. Now, I've got 3 equations here, okay? At every step, I'm going to still have 3 equations, 1, 2, right under 1 to 4, okay? And the X's are lined up, the Y's are lined up, and the Z's are lined up. So you don't go blind looking at a Y here and a Z down here in the same column. Okay? So these are like columns, and you really want to set it up that way. Before we're done, we're going to set this up as a matrix. And that'll force you to do the columns. But right now, we're going to do just with the cells, okay? Now, I set this up. Getting something from the class next door there, and I started to pay attention to it. It was drawing my attention. Okay, so we have we have these 3 equations. Now, we want to eliminate a variable. Okay. If I pick on Z here, this you got a 1Z here, right? Easiest way to eliminate a variable, and it's not hard to eliminate others, but the easiest way to eliminate a variable is to pick on the easiest one, which is Z, because if I multiply the second equation by 7, then this is going to be a 7Z, this is going to be a negative 7Z. So if I add this equation to this equation, Z is going to go away. Okay, so the way I write this is, okay, I write down equation 1 from before, because I'm not going to do anything to it right now. Okay. Now equation 2, I'm not going to do anything to it. Equation 3, I'm going to multiply it by 7, which is going to give me 77x plus 7Z equals 49. Okay. Now, with these 2 equations, I can add this side to this side. I can add this side to this side. And what I get is still going to be an equation with 2 equal sides. Okay. So if this is equal to this, and this is equal to this, and when I add this to this, it's got to be equal to what I get when I add this and this. Okay. Okay, so again, I'm going to keep equation 1, which is 5x minus 7y equals 11. But now I'm going to do equation 2 plus equation 3, where 3 is now, when I'm looking up, 3 is going to be the 3rd equation in my list. Okay, so this is my new 3. And this one is looking at the wrong thing here. 77x minus 5y equals 14 and 49 is 63. Now, do we understand what I did here? I added this equation to this equation. When I add this side to this side, I'll have a negative 7z and a plus 7z, so I'm not going to have a z there. I've got a negative 5y here, no y here, so I've got a negative 5y down here. I've got a 77x here, so I have a 77x here. And of course, then I add the 14 to the 49, that gives me 63. So I've added these two equations. Get this equation. Now things get a little complicated here, the numbers get nasty. But we're going to do it anyway. I want to eliminate a variable with these two equations. And the way I'm going to do that is I'm going to multiply this one by -5 and this one by 7. So multiply this by -5, I'm going to have a negative 35y, 35y. Multiply this by 7, I'll get a negative 35y. Okay. So I can always, if I want to eliminate a variable, I can always multiply this one by this one, or it's negative, okay? And then I can multiply this one by this number. So I can multiply this one by 5, multiply this one by 7, I'm going to get 35s. Now, if you don't like that, no reason you should. I could always multiply this one by 5 and this one by 77. And by the time I multiply 77 by 11, I'm going to get 847, I think. Of course, I'm still going to get big numbers here. If I multiply this by 7, I'm going to get 441, I think. Okay. So you're kind of stuck with big numbers in this case. And that usually won't be the case in the problems you see, but if you got big numbers, you got big numbers. You got a calculator. Okay. Okay, so what I then do is I multiply, let's come up here. I multiply equation 1 by -5 and equation 2 by 7. And multiply this by -5. We'll write it out. What do I get when I multiply this by -5? What do I get when I multiply this by 7? Go ahead and do that step. Okay. So I think everybody's got the idea here. Other than maybe the idea of keeping everything in a nice column so that you can see where everything comes from. So you can distinguish your side calculations from the development of the problem, right? Okay, and then we're going to keep doing this until you do, but you're almost there. Okay, you want to pay attention to that, otherwise it gets very, very confusing. And it's also a cruel thing to do to me because I've got to try to evaluate what you did, and it's scattered all over the page. And maybe on some pages you forgot to turn in, I don't know. Okay, well, it's not so much about taking it easy on me. I know what I'm looking for. Seriously, it's about organizing it so you can see what in the world you did. Okay, and so you see the development of the whole system. Okay, well, you're good. You're good. Okay, because everybody's pretty good. Okay, and not everybody did these two equations, but everybody did two. Some people did the two equations I got from their own numbers. That's okay. The people that did it based on these equations got the same result for X. And it was really good to see that. So organized or not, some were better organized than others, but I'm pleased to see you did it right. Okay, so anyhow, what do? You take the first equation, multiply by -5, you're going to get, well, -5 times 5 is -25. -5 times 7 is 35. -5 times 11 is -35. So let's see if I can remember what I just said. You got -25x plus 35y equals -55. Did I do good? Is that what you got? Keep an eye on me. Okay, And then the second one by 7. Okay, now when I got 841, I'm not sure what I did. I multiplied this thing by 27 instead of, I don't know. Okay, anyhow, I multiplied this by 5. Oh, sorry. Multiply this equation by 7. Because that's going to give me a negative 35 here to match up with my 35 here. And 7 times 77 is 490, and 49 is 539. And 7 times 63, I think is 441. Am I right? Okay, what I didn't just now. And something is wrong here because that has to. You want these to match up with equal and opposite coefficients. You can always have the same coefficients and then subtract equations. But if you're subtracting equations that have negatives in them, it gets error prone. Real easy to make a mistake. Not really hard, but it's error prone. It's hard to keep it straight. So we want to have equal and opposite signs in one of these variables, either X or Y in this case. So now I just add, and that's very easy. I get 514 X equals 441 minus 55 is 486. Is that right? 386. That what you got? Okay. So that clearly then X equals 386 over 514. Now this could be reduced. You can do prime factorization here, prime factorization here, and reduce the fraction. But when the fractions get like this, it's generally okay to go ahead with a decimal approximation. Let's say to 3 decimal places. Anyhow, so what do you get here? This is going to be like a 0.68. What would it? Yeah, let's say. Okay, what do you get? And actually, did I do that right? Yeah, I did. So it's. Okay, I thought that was nil for 6. Okay. It's 0.75 approximately, maybe it's 76. But that's reading off your comfortably. Okay. I can do that in my head. That's what I was on. So okay, so that's good. Now that you got X, what can you do? Well, I say go back to one of the original equations and solve for Y or Z. Okay. If possible, I can take this back to an original equation and solve for Y. I can plug my value of X in here and solve for Z. That's not always going to be possible to do that. If this had a Y and a Z in it, and this had a Y and a Z in it, then I wouldn't be able to immediately solve for Y or for Z. Then I'd have to go back to one of these equations because these two equations both have X and Y. Okay, but one of these two. Because obviously, even if I have a Z cluttering this one up and a Y cluttering this one up, I can go back to this. If I plug in X, I can solve for Y. And then I'd have values of X and Y that I could use for another equation. Well, we'll get to an example where we have to do that. But we plug this in. I'll use my big old arrows. We plug this in. How am I going to get up there? We can actually plug this one into the first equation, which gives us this. Well, I'm going to say, I'm going to use a decimal approximation instead of having to do fraction. But with your calculator, you could easily do it with a fraction. And I got 5 times 0.75 minus 7y is approximately equal to 11. And that's 15/4, which is 3.75. So I get 7.25. So I get approximately equal to 1.3. If I did it right. Then I can plug X back in here and I can get Z. And I'm not going to actually write that one out, but we want to eventually do that. And I'm going to get what? 8.5. That's negative 1.5. Basically, is about negative 1.5. Then we plug numbers in and see if that works out. 5 times negative 1.3 is negative 6.5. And 7 times 1.5, negative 1.5 is 13. Well, that doesn't really work. Oh, it's X. 5x is negative 3.75. That's positive. And that's going to be Y. Still doesn't work. Okay. Not going to go through the details. We plug these 3 numbers in, whatever 3 numbers you get when you do it accurately with your calculator. And then we plug those numbers in to one of the equations we haven't used and see if it works. Ideally, we plug it into all 3 equations and see if it works. Okay, I'm going to give you another set of equations. And this one I'm going to design so you get easier answers. So you really see where the numbers are. It's easier to check. I couldn't do that using variable numbers. I wanted to see what you would do with that. So let's say we got 2x minus 3y plus 5z equals m. For x plus 6y minus 10z equals 0. And then x minus 3y plus 4z equals 8. So this will be your equation 1, this will be your equation 2, this will be your equation 3. Your goal here is going to be to start by eliminating x from the first 2 equations. Okay. And then I'm going to change the number here. 2 numbers. Instead of 7, here I'm going to have 6. And over here I'm going to have 7. Okay. Now, if you look at this, it's easy to eliminate X between this equation and this equation, and also between this equation and this equation. Okay. So see if you can do that. Okay, now I'm going to organize this a little differently than I did before. I really want to show you the organization of the scheme. If I get this chalk box open, I have a piece of chalk to write with. If I have to rip the whole thing apart. Okay. Now here's what I'm going to do. We notice that if I double this equation or multiply this equation by -2 and add it to this equation, it's going to eliminate the x's, right? Well, here's what I'm going to do. I'm going to write down equation 1. I'm not going to change it. But I'm going to keep it. And instead of doing what we did here and what we have done, I'm going to do this. I'm going to say I'm going to combine everything that you did, and I think did correctly, okay? I'm going to say I'm going to take -2 times this equation and add it to this. Because I see that if I do that, I'm going to eliminate x. Now, I'm not going to calculate -2 times the first equation plus 2 here. I'm going to go over here so that I keep everything in a column. So I'm going to do this. You say, okay, let's see. -2 times the first equation, -4x minus 3y plus 5c and 6x. 6y 10z equals -8. Can't even read it. Okay, try again. -2 times the first equation. That's the first part of my calculation. Gives me 4x minus 6y plus 10z equals 8. Then my second equation is 4x plus 6y minus 10z equals 0. Well, this gives me, and it's -2, so something is wrong. It should be -10z. I'm doing this very carefully. Plus 6y -4x. Okay. Calculation that you did, and you actually wrote it down correctly. I finally think I have it correct. Then if I add these, I just get 12y minus 20z equals -8. So I do this off to the side, and then I replace the second equation by this, which is going to just be 12y, not 12x. Minus 20z equals -8. Okay. Now that's what you get. If you multiplied this one by 4 and this one -4 and this one by 2, that's fine. You would have gotten 24y, -40z, -16. Just double these numbers. Because you multiplied by twice as much as I did. Okay. And why did I choose -2 times the first equation, because -2 times 2x already matches the 4x. I didn't have to multiply this by anything. Okay. What am I going to do to eliminate x between these two equations? Well, it should be clear that if I multiply the first equation by -3 and add, I'm going to eliminate x, right? So I'm going to say, okay, now I'm going to do -3 times the first equation plus the third. And I don't really have to write that out, but often I do. Now, let's see what happens if I just look at it. I say I'm going to get a -6x and a 6x here, right? That's going to add up to 0. I'm going to get -3 times -3y, which is plus 9y, and minus 3y. That's going to give me 6y. -3 times 5z is -15z. Added to 4z gives me minus 11z. And -3 times 4 is -12. I add that to 7, I get -5. That's what I get if I do this calculation. Now, just to check it out and make sure I did it right, I do it over here. -3 times the first equation is -6x plus 9y minus 15z. That equals -12. The third equation is 6x minus 3y plus 4z equals 7. Now, if I add -6x and 6x, x goes to what? I add 9y and -3y, I get 6y, -15z, 4z is -11z, -12 and 7 is -5. So I can check this with this. Notice now I'm writing these calculations off to the side so I don't clutter up these columns. Okay. So here I have a system of 3 equations. And here I have a system of 3 equations. Notice that this system still contains the first equation, which I haven't changed. It now contains 2 equations and 2 unknowns. I've eliminated x, so the only unknowns I've got left in these 2 equations are y and z. Now, what can I do to eliminate y here? Okay, I can multiply this by -2. I can add it to this, right? That's going to give me just an equation in z. So I'm going to do that, but not yet. The other thing I'm going to do is, oh, never mind. I'm just going to do that. And I'll show you what. Okay, so I'm going to write my first equation. And that is just the first equation from before. And I'm going to write my second equation. Not going to change it. And then I'm going to add my second equation to the third equation, which I first multiply by -2. And so I can do that. And let's do it off to the side. Okay, the second equation now is 12y minus 20z equals -8. And -2 times the third equation is 12y. Or third equation minus 22z equals And I think that's plus 22 equals 10. Okay, Y's go away. C's add up to 2z. And the numbers here add up to plus 2. So that my equation down here is just 2z equals 2. Okay. Then I solve this equation for z. I've got 2x minus 3y plus 5z equals 4. I've got 12y minus 20z equals -8. And that's my equation 1. This is my equation 2. This would be my equation 3 from before, divided by 2. If I divide both sides by 2, I get z equals 1. Okay. Now, if you look at the sequence of what I did, I first eliminated all the x's in the second and third equation, so I don't have any x's down here. Okay. Then I eliminated y's between my second two equations. Now I don't have any y's down here. And this is what we call upper triangular form. Upper triangular form makes the rest of the solution very, very easy. I simply solve the third equation, which only has z as the variable, one variable. I solve that easily. And now what can I do? Well, z is 1. I can plug that in here and solve for y. Then I'll have y and z values that I can plug in here and solve for x. Okay, so you probably don't have these equations. I didn't actually tell you to put it in upper triangular form, but I've taken the operations that you're now doing correctly, okay, and organized it in a way that gives me something that's going to be really easy to solve. So what I'm going to ask you to do is write down these three equations and then see what you get when you plug in z here. I'm going to be able to solve for y. Then you can plug y you just found and the z you already know in here and solve for x. Okay. Let's make sure that this is all on the screen. Too far. Okay. Okay, so here's my upper triangular form, and now I've repeated the upper triangular form here. So if I take z equals 1, just plug that in right here, I get this. Which is really easy to solve. 12y minus 20 is negative 8. 12y equals 12. Y equals 1. So now I've got z equals 1 and y equals 1. So plugging z equals 1 in here gives me this. Plugging z equals 1 and y equals 1 both in the first equation. Oh, my z equals 1 is going to go there. My y equals 1 is going to go here. It's going to give me 2x minus 3 times 1 plus 5 times 1 equals 4. Two x plus 2 equals 4. 2x equals 2. X equals 1. We don't have time right now, but now my solution I'm going to write it this way. And we're not going to get to it today, obviously. But this actually could be the coordinates of a point in space, in three-dimensional space, where you have an x-axis and a y-axis and a z-axis. That's a little harder to visualize. We haven't done much with it. It turns out that each of these equations, just like an equation of just x and y, can be depicted as a line in 2 dimensions, right? Okay, we know how to do that. Each of these can be depicted as a plane, a flat surface at some angle in 3-dimensional space. Each one is a plane. The planes can intersect each other, and these 3 planes intersect at a single point, and this is the point. Now, you don't have to know that at this point, but just kind of an idea. Wanted to plant so you can kind of let it grow a little bit. That's one reason we might want to write down the solution as an order trip. And you might be asked to do that in some of the thing I want to stress is your solutions should look like this. Because next time we're going to put these into matrices. I'm actually going to add, if you got to go ahead. But yeah, check out the video or whatever. I could write this equation as, or this system as 2, negative 3, 5, 4. Where I understand that the first column is going to be my x coefficients, the second the y's, the third the z's. It's easy to see that these numbers here represent these equations. The reason I want these organized columns and so forth. So this equation, then just by acting on these numbers the same way we acted on the equations themselves, reduces down to the form 2, negative 3, 5, 4, 12, -20, -8, 1, 1. It's zeros here, here, and here. The zero is what I kind of want you to see. We got a 0x, 0x, and a 0y. We pick those as zeros. Okay. Now that's what we're going to do next time, but just seeing that this time, and kind of how it connects to these equations shows you a little bit more about the format, and then we'll pick up on that next time.